So we want to know how to identify the VORs, the radials, how to track and intercept them, as well as like DMEs use either distance measuring equipment, or we're going to do a DME arc, things like that. So we'll talk about that a little bit. If you guys have questions, definitely ask. And then we will go into our ILS and its components, or our instrument landing system. Everything that we are going to go over today, you can kind of dig into a little deeper, have additional information. It's going to be in your Instrument Flying Handbook, Chapter 9, going over those navigation systems. So VOR stands for Very High Frequency Omnidirectional Range. So the station sends out a signal to your VOR. So each signal is specific course, either to and from the station. And the way that you would identify it is via Morse code. So most of the time you're going to look at your chart, you're going to see what the Morse code is. You can even look on your approach plate while you're trying to figure out where you want to go, what you want to tune an ID to, and what the actual identifier is for that. And you're going to listen for that Morse code. So they usually transmit between 108 and 117.95. That's that very high frequency that they talk about there. So most of the time they're going to tell you what service volume that VOR has on the chart or the approach plate. So we'll take a closer look at that in a little bit. But on your G1000, you are going to hit the ID button. So if you push this in, it's going to give you the ID button. The really cool thing about the G1000s is it's actually going to give you the identifier there. So that way you can make sure that you have it tuned to the right frequency for the VOR that you're actually looking to tune into. Also, if it shows up, it's also indicating that you're within range of that VOR. So the antennas on the back of on the tail of your aircraft, that is your VOR receiver antennas. So again, if you do a walk around, those are the antennas that you look at. Make sure that they're in good condition. Obviously, there's not bent or anything broken there. And then you also have, other radio antennas, GPS antennas, and whatnot. Just know where those are, because I've had DPEs ask students before, and they have kind of bumbled that, because again, once you go through private, you've looked at everything on the outside of the plane, you've practiced it, and then you come into instrument, and then you kind of forget all about that. And so just don't let that happen to you. Don't take it for granted. Actually know where your transponder antenna is, your VOR antennas, GPS antennas, and things like that. All right. So again, when you do a walk around, just make sure that you are still up to snuff. You know exactly what each of them go to. Benjamin, welcome to class. I'm going to go ahead and post the sign in link one more time.
Yeah, sorry I joined a few minutes late. I was having internet issues.
No worries. You're still within my time frame that I allow students. If you have questions, we did go over like 2 or 3 slides already, but I think it's more review. If you guys have questions, definitely slow me down, or if there is a slide that maybe you want to take a picture of, let me know. All right, so you got the sign-in link, you're good to go. All right, so our traditional equipment is you usually have an omni bearing selector, and you'll rotate that. You have your CDI, your to and from flag, and then your rotating course card, right? That's your traditional one. Again, it works the same way with the G1000. The good thing about the G1000, we're about to go over some of the limitations and errors that they have, where the traditional VORs had those errors where, the GPS, the G1000 doesn't have those errors, or don't give you some of those errors there. So with the VOR types, we have, just make sure that, again, you understand the chart symbology of it. So here's your VORs. This is exactly what they look like here. You're going to have your Morse code identifier, your actual identifier for the VOR, and then it's going to give you an L here. So the L is going to show you that this is a low service volume, VOR. And then you can see here, this one has the H next to it. So these ones are DME VORs, and then this one is your VORTAC. So again, if they're filled in, they're compulsory reporting points where you need to let ATC know that you are over that VOR, VORTAC, so on and so forth. But again, the service volumes are actually found right next to the Morse code identifier. So it is good to know that. And so then understanding the actual service volumes that you have. So you'll have a terminal VOR, your low, and then your high. So if you're under the 14,500 for your traditional service volumes, you have a 40 nautical mile service range, right? And then if you're under 18,000, then you have, I don't know what just happened. If you're under 18,000, you have still 40 nautical miles, but this one is the low version in the traditional. And then with the new service volumes, you again have between 14.5 and 5,000 70 nautical miles, and then the very low. So you'll have the VL will be displayed next to it if it has the new service volumes. As you can see, these traditional ones, oh, it's not listed there, but it's usually, that's the L or the H. So this one is a traditional one, but if you see it next to on the chart and it has the VH or VL, then it's the new service volume. So then you know what those are. So I do highly recommend having this bookmarked in your AIM. Again, it's going to be AIM chapter 1. I think it's 1-1-18, I believe. But it is very easy to find. I would bookmark it. It's definitely something that does come up with a lot of DPEs. They want to know if you know the service volumes from the old service volumes and new service volumes and what they are. So again, determining whether you have the low or high or terminal, like I showed you before, you're going to have the L. This is going to be your traditional. This one's going to be the high. So here's a VORTAC and a VORTAC, and you just want to know, you quickly identify that just by looking at it. If it's going to be the new service volume, like I said, it's going to be that VH or VL. With the VOR limitations, they are line of sight. So while you are en route, you'll have an MEA and you'll usually have a MOCA, right? So again, it's line of sight, that MOCA. If you're below the MOCA, you probably won't receive the VOR if you're too far away or if you're too low, right? So this would be like an example of this. So you'd want to be able to be high enough where you could receive both. And then depending on what the service volume, understand that the service volume is the limitation of how far it can reach, right? So then misinterpreting it or reverse sensing, if the VOR is down for maintenance, again, you're going to hear a test Morse code. So it's going to be basically the 4 dots. That's what the Morse code is going to sound like. So that means that it is in a test mode. So you're not going to be able to use it. And so really understand the service volumes, know what the test Morse code is, so that way you don't accidentally try to use a VOR that's not in service. And then reverse sensing, like I said earlier, if we have our G1000 and we're using the G1000 VOR, we're not actually going to reverse sense. The G1000 prevents reverse sensing. So that's a cool thing, a cool feature about G1000s. And then misinterpretation, that's on you, right? So again, maybe not picking up, tuning and IDing to the correct VOR, or maybe not picking it up, or thinking that you have it, but you're not. And then of course, line of sight. The other thing is the cone of confusion. So anytime you have station passage, when you're approaching the VOR, the CDI needle is going to oscillate like crazy. So the numeric bearing is going to be removed. You're not going to have that anymore. So a lot of the times when you know that you're going to fly directly over the VOR, you're doing it on purpose. It's really beneficial to bug your heading, because again, you're gonna try to, like I said, that bearing is going to be removed and you're trying to fly that, but then it's oscillating back and forth and you're scanning your instruments. So if you don't have your heading bugged, you can actually get disoriented. And then inaccurate or erratic to and from movements. So once you finally passed the VOR though, you're gonna have that bearing pointer, that CDI, and all that data come back. So that is the cone of confusion. They actually have it drawn like this because of course the lower you are, you'll pass through it a little more quickly. The higher you are, it might take a little bit longer for you to pass through that cone of confusion because it's shooting the signal straight up. All right, and then to navigate to the station, right, easy enough, you're going to rotate your OBS to a 2 flag, so until the 2 flag appears. And then you want to fly that CDI directly on course. So again, if you are anywhere, so this plane is looking this way, right? But if we wanted to fly to this VOR, we are actually going to rotate the CDI knob until it shows us a 2 flag. And if we want to fly directly to it from our position, we're going to continue to rotate it until that CDI needle has centered. And we want to make sure that we keep it centered when we're flying to the station. So I'm just assuming that you guys understand this concept. Does anybody have any questions or is confused on how this works? No? All right, awesome. So again, if you want to fly the radio, you'll tune an ID to that radio with a from flag and you'd be able to fly from the station. Now, tracking and intercepting a course, a lot of students seem to kind of get this a little bit confused. So I'm going to give you an example, right? So if you wanted to track a course of 250, and this is your radio, let's just call it Victor 144. I'm looking something up, right? So this is Victor 144, and you want to, and it's on a radio of 250. You take off of runway 21, and as you're climbing out, you're trying to figure out how to re-intercept this course so that you can get on that Victor 144. So you're going to find the difference between your current radio and your desired radio. Now you're going to double that difference to find your intercept angle, because again, you always want to be more, you want to have more turn so that way you'll intercept it more quickly. And then as you see that needle coming in, you're going to just catch that needle right while it's centering up and then fly it outbound. So you're going to turn to intercept that heading and hold that heading until the CDI intercepts. So here is kind of like the easy math of how to do that, right? So again, 250 minus 215, that's the runway we took off of. 35 multiplied by 2 gives you 70. So you're going to take 70 and you're going to add it to that 215 heading to get a heading of 285 to get you intercepted, and then you'll fly outbound on that. And again, if you were having to intercept to the left, then understand that you are going to subtract. Does that make sense to everybody why you would subtract? Yes. Okay, awesome. All right, so VOR checks. Who knows what the VOR checks is? This should be kind of a review for all of you guys. Because now you guys are all pilots. Anybody want to chime in? What are the VOR checks that we do that are available to us? Ground checks, air checks. What is the bearing error that's allowed? Plus or minus 4, very good. Now, for the air checks, what is it? Plus or minus 4 for ground checks, but what is it for the air? Very good, plus or minus 6. All right, so we do have, what do we normally do with ATP planes since we have VOR 1 and VOR 2? Anybody? Dual VOR? Compare the two, yeah. So we do a dual VOR check. Yeah, absolutely. So you still have the same bearing error that's allotted to you. Does anybody know what a VOT is? Or where to find it, rather? Chart supplement, yes, wonderful. Yeah, and I know that everybody is in different locations all over the US, right? So here in Florida, if I look at Florida and I'm looking for a VOT, there isn't one. The nearest one to me is in Alabama. So again, you guys want to look and see where the nearest VOT station is. This is an actual test facility that you can fly to. It does give you more accurate reading, but dual VORs is commonly what we use. And so it's just not, it's good to be, aware of all of the different ones and the ones that are available to you. So again, there might be ground checks at your airport. Make sure if there is that you know exactly where it is, bookmark those, be able to talk about it again with the bearing errors. Does anybody know what you are required to do when you do a VOR check? What are the 4 things that you have to do? So you're going to want to put it in the maintenance logs. So you want to have the date of the check that you did, the bearing error that you noticed, what type of test you did, and then your signature. There you go. Nicely done, Wyatt. Yeah. So those are the 4 things you want to do. And then how often do we need to do the VOR checks? Very good, Hunter. Yes. So every 30 days is a VOR check. So again, lots of DPEs love to talk about VORs, VOR service volumes. They understand that this is probably something that is, there's just more steps, there's more things, and they like to kind of have people talk about it because they understand that this is more of an area that people are a little bit more uncomfortable with. So again, make sure that you are on top of your VOR knowledge, because there are lots of DPEs out there that like to talk about the errors, all the different types of checks, how much there is, how do you tune an ID, how do you track a radio, how do you do a hold off of a VOR. So again, you want to make sure that if you have any questions, feel free to ask, but make sure that you have good understanding of this and that you feel very confident talking about these. The VORs, you are able to even identify the symbologies on the chart and whatnot. So VOT stands for, that's a great question actually. Anybody want to take a hack? I'm actually gonna pull it up in the AIM. I can find it. I'll get back to you actually, because I don't want to tell you the wrong thing. I forgot exactly what it stood for, but I will look it up. And we have time because I know I'm blowing through this lesson real quick. So you guys look it up in your chart supplement on your ForeFlight. Like I said, you should have that bookmarked, that page. And you have to have the entire supplement downloaded. So VOT, it's a VOR test facility is what it technically stands for, even though it says VOT. So VOR test facilities is what a VOT is. So, and then it is actually on page 513 of 769 if you guys actually have the chart supplemented downloaded to your ForeFlight. So again, I have a bookmark for that Because again, you just want to be able to find the one that's in your state or at least closest to your state. And like I said, there are some places that don't even have it. All right. Okay, moving on, let's go ahead and review the 4 components of an ILS. Yeah, test facility. Thank you, Lindsay. All right, so Eric, do you know the 4 components of an ILS? You're welcome to unmute if you do.
That's an indicated landing system, right?
Instrument.
Instrument landing system.
Yeah, very good.
I don't. Was this in day 2? Because I haven't taken day 2 for like months.
That's okay. No worries. No worries. Anybody else want to help them out?
Yeah, I got it.
Okay, thanks.
It's the glide slope, the localizer, it's the approach lighting system, and then the marker beacon.
Very good, right? So you use the GLAM acronym to help you with that. And then I see, Chris, you also got it as well, right? And so instrument landing system is our precision approach landing system that we have. It's actually our only precision approach that our aircraft is capable of doing. With GPS, we're able to do precision like with an LPV. So our instrument landing system, we do have marker beacons. You'll have your outer marker, your middle marker, and your inner marker. You also have frequencies that let you know whether you're left or right of course, and then either low or high on your glide slope. So there are the components to it, right? So you have your localizer, and then you have your glide slope, and then you have your marker beacons plus the approach lighting system like you guys were talking about. And so again, with the 2 frequencies that are shot out from the system, it can tell if you're picking up more of that 90 hertz, then you're going to be left of course. And so then you're going to need to correct to the right. If you are low, you're going to pick up more of that 150 hertz. And so then you know to, in order to re-intercept your glide path, you're going to want to try to maintain altitude to re-intercept before following it down. The interesting thing about the instrument landing systems now in real world is that there are a lot of the ILS systems that don't have physical marker beacons. So again, these are actual systems that are on the ground that give off a signal, and then you are able to pick up the signal. Does anybody know what the color indications are for the outer marker, middle marker, and inner marker? There you go. Very nice. Yeah. So you got your blue, your white, blue, and amber. And so again, it's very specific. You should look at I don't know, maybe I like being curious. I like to look at different instrument landing systems to see which ones actually have a marker beacon and which ones don't. A lot of them just use distance now. So you have your final approach course, and then you'll see distances, and then you would go ahead and, what do you mean, Lindsay? British Airways? You can unmute too.
Sorry. Blue, amber. Wait, so just how you remember it?
Oh, yeah. Okay, gotcha. Thank you. I appreciate that. I never thought of it that way. So again, lots of the instrument landing systems don't actually have the marker beacons there anymore. So again, if you do with your G1000 airplane, it's actually going to show you the O, the M, and the I in there as you're coming in. So as you are coming in, if they do have one, it's actually going to light up. It does have a Morse code to it, and so those are the things that you're going to want to be aware of too. So not every one of them has it. Lots of them use distance now to measure instead of the actual marker beacon itself. But again, every time you talk about an ILS system, I'm not saying don't omit that altogether. I'm just saying it's just an interesting kind of fact, the way that the system is kind of changing over. So where is the localizer positioned? It's going to be at the end of the runway, because I kind of already pointed that out. And then how wide is that runway threshold? Or is it at the runway threshold? Anybody know? Very good. Yes, 700 feet. So again, sometimes this is like a hit and miss. Sometimes this is asked in a check ride. Sometimes it's not. It is very possible you can see it in your written test for those of you who haven't taken your test yet. But I highly recommend, if you have taken your test, go ahead and go back through the ACS, mark all of it. And if you have anything with the ILS system, just make sure that you feel really confident talking about all of the components and where they're located and whatnot. So what are the two signals transmitted, or why are there two signals transmitted instead of one?
I'm gonna guess it measures the difference between the two to figure out where you are.
Right? So again, I did kind of mention it, right? So you have two signals. So that way, if you're intercepting the two signals and you're getting the same amount, then you're right directly in the middle of where you need to be, whether it's your glide slope or your lateral guidance. And then if you are receiving one signal more than the other, then of course it knows whether you're left of course or right of course, or whether you're low on your glide slope or high, right? And that's how you get your indication. So that's why you have the two signals. So just like it's showing you here, it shows you if you're getting that perfect, even number of 150 hertz and 90 hertz, you're right down the center line. And then if you're a little left of course, it's going to show you you're left of course. And so you need to correct to the right. So you're getting more of that 90 hertz. Does that make sense to everybody? Very good. All right. So what is the localizer's service volume? What is standard anyways? They're 10 nautical miles. So it's not 35 miles, it's 35 degrees, right? So it's 10 nautical miles out is that first one. And then it's 35 degrees. And then it's 18 nautical miles out. Very good. And 10 degrees. So that is your service volume there. So this is standard, because there's actually a lot of bigger airports now that have ILS systems that their ILS will actually go out a whole lot further. And so if you fly into any of those areas, you're actually going to be able to pick up the ILS, the localizer signal, pretty far out, a whole lot further than 18 nautical miles out. So again, but this is your standard. This is what they want, textbook answer. This is what you need to be telling the DPE if you get asked this question. So it's 10 nautical miles with 35 degrees from center line, and then it's that 18 nautical miles with 10 degrees from center line. So it looks like this. So these are your normal limits or standard limits, and it's also found in the AIM 1-1-9. All right, so where is the glide slope located? Anybody? You guys usually pass it.
Approach into the runway. It's either on the left or right hand side.
Very good. Yeah. So it's usually 750 to 1250 down the runway. And then what is your typical angle? This is pretty much normal for all your glide paths all the way down. Yes, very good. 3 degrees, right? This is your normal. So again, you'll either have 50 hertz down. If you're low on your glide slope, you're going to be getting more of that 50 hertz. And so you need to kind of level off to re-intercept your glide slope. If you're high, you're going to get more of that 90 hertz. So you're going to want to increase your descent rate. All right, so your marker beacons, there are 3 different colors. And then I do like Lindsay's version of remembering the colors and the way they are. So again, British Airways, so you got your blue, and then you have your middle marker, which is amber, and you'll have your inner marker, which is white. So they are the different ones there. And like I said, these are actual physical things on the ground. So not every location, every ILS system has all three of these. So don't let that confuse you, because again, sadly, I've had some of the students who have gone through the program, when they were asked, to the DPE to show them where the middle marker was, they didn't know how to do that because it wasn't on the chart, because that physical ILS system didn't have it. Now, again, I think that DPE was trying to be tricky and a little bit mean, but I now kind of point that out to people, all right? So again, just because it's part of an ILS system or can be part of an ILS system doesn't mean that it's always there. All right, so your approach lighting system helps you transition to your visual approach. And so I like to point this out. Does anybody know what approach lighting system this is? Bonus points. This is just for bonus points. Yes, the ALSIF 2. Very good, Chris. Yeah, so this is the ALSIF 2. So when you guys are talking about 91 175, does anybody know that from memory yet? Definitely is something that you should know. In that regulation, I definitely highly recommend that you guys have that memorized, but it talks about the 2 red side row bars or the red terminating bars in that third part of that regulation, and it is specifically talking about the ALSIF 1 and the ALSIF 2. So if your airport has a Mauser or a MALSIF or ODLs or whatnot, then that portion doesn't apply to you. You have to have something else come into view. So again, 91 175 is just talking about when you can descend past your DA and MDA, right? So again, just understand when it's talking about the red side row bars or the red terminating bars, it's talking about these 2 specific approach lighting systems. If you have any other approach lighting systems, you have to have something else come into view. Nicely done. All right, so we'll go ahead and do our little pop quiz and we'll take a break. So what are the different types of conventional VORs that civilians can use? Have all of you answered yet? No. Okay. All right, very good. So yes, you guys are in agreement and correct. So B is the correct answer. We have VOR, VOR DME, or VORTAC. And so that is what we're able to use in our aircraft. What are some indications that we are approaching station passage of a VOR? Very nice, very nice. Yes, so D is the correct answer. We were talking about how the CDI needle will oscillate and go full scale deflection. Your bearing will disappear, and then it's super erratic. The to and from flag will flip back and forth. So again, if you know that you're doing it on purpose, you're trying to fly over the VOR on purpose, bug your heading and make sure that you just wait for it to even out. So a lot of people kind of get disoriented. They'll like go off heading and then they'll also dip down or maybe even climb up. So just be cognizant of that if you're flying over a VOR. So where can we find graphical information about what is included in the various approach lighting system? Very good, very good. Yes, so C is the correct answer. So again, we can find it in our digital terminal procedure publication, the TPP, and then our AIM as well. All right, and then the traditional DME uses slant range, true or false? No, very good, very good. Yeah, and so we don't actually have DME in our aircraft. We have GPS, and we use GPS in lieu of DME, so we don't have slant range. All right, we'll go ahead and take a break. Let's do a 15-minute break. We'll come back, and then we are gonna go into GPS.